Welcome everyone to our very last lecture, lecture 16 on mobile manipulation. Well, it's been quite the semester, a long course I know, but now you're here at the culmination of our systematic approach to learning programming through ROS, and we're getting to a really interesting level of integration, as you'll see very soon. So I'm very excited to go through this lecture with you, and I hope you feel excited with me as well. So finally, here in chapter 17, we're going to be integrating, as usual, the things we've been coming with: modeling, perception, manipulation, but finally we're integrating navigation to come up with this mobile robot that can do manipulation and perception. So this is a really advanced scenario whenever we're doing mobile manipulation. So let's dig in and take a look. Now I realize that in this course we have not yet covered navigation. That is part of chapters 9 and 10. And so part of your homework will invite you to go and study those two chapters to learn more about capabilities of ROS for navigation as well as foundational ideas. Now for extra resources, you can also look at the ROS by Example textbook 1 and look at chapters 7 and 8 that will give you a similar but different overview. Now I should mention for the class resources, I have two PDFs that cover exactly these two chapters. And then for a more advanced scenario, you can look at chapter 3 of ROS by Example 2, where you could extend your mobile navigation with Smash. And so it'd be really interesting at the culmination of this class to implement what we have here into a Smash framework to give you even a higher level of control and execution for your robot. Okay, let's go to 16.1 to the mobile manipulation model. In fact, this is not going to be too different from what we saw in the previous chapter. We're going to have a Sacro file, Baxter on Mobot, as part of the Baxter Variations package. And so here we're just adding that one extra integration, which is really the Mobot. So we have the regular Baxter, we have the right and the left grippers, we have the head-mounted Connect, and now we're going to integrate the Mobot. So for convenience, the Sacro file is right here. And so you can see the very first file that we include is the Mobot base.sacro, and then the Baxter base, you already have Sacro, and the left, the right, and the effectors, and the Connect. The thing that's missing, though, is the connection between the Mobot base and the Baxter robot. So here at the very end, we need to create one additional joint. We're going to call that Baxter base joint. It's, of course, a fixed joint, and that's where we link as the parent, the Mobot top link, with the base of the Baxter robot. And we have a slight change of coordinates there for x, y, z. So this is the way that we connect the robot, and then we're going to be able to visualize our mobile robot, as we'll see in the next section. See you there.